Well, a warm welcome indeed to anybody here. Thank you for joining. Go ahead and get yourself ready with a notebook. You can grab a pencil or a pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we have an important exploration of a very simple topic. This is not going to be mind-breaking, or rather mind-blowing / ground-breaking information, but it's a healthy reminder, especially for students that are stepping into pre-calculus, and crucial for students to understand once they get to calculus. Now, this is the zero product property that I'm talking about. And it's very simply displayed, or it's very simply set up, that is, on the board so far. We just have A times B equals 0. This means that the product of these two objects, they're most likely got some values, some numerical values. And if you multiply them together, you get 0, which tells us, in fact, the zero product property basically says if A times B equals 0, then A equals 0 and or B equals 0. Now, what do I mean by and or? I guess I won't really put and or. I'll just say that we should consider the possibility that A equals 0, and we should consider the possibility that B equals 0. So not going to get into the logic of the semantics, but in strict logic, especially with mathematicians, when we say or, we just mean at least one of them. Doesn't necessarily mean only one or the other. Now, why is this so important? It looks like such an obvious, simple concept, and it is. When we're in calculus, we're going to be setting things equal to 0 a lot. And when I say setting things equal to 0, I mean we're going to be setting some potentially gnarly expressions equal to 0. We might have something like e to the x times x cubed minus 3x e to the x equals 0. Like, that looks kind of gnarly, right? And the purpose of this video is twofold. It's not only to remind you of this very basic property, which allows us to progress forward at some point in the problem, but it's also to emphasize how important factoring and how effective factoring is for solving equations. When we're able to factor, it's sort of a luxury. We're not always able to factor certain expressions, but you should be looking out for when we have the opportunity to factor. If you're not as advanced in math, maybe you're just in Algebra 2 or pre-calculus, the factoring of this could be kind of tough. But what I'd like to mention is that a common factor in both of these terms is e to the x. And another common factor is 1 power of x. We have 3 here, but we can only take one that's in common. So it's common to write x in front of e to the x, leaving us with x squared minus 3. And now you can see we have a situation much like at the top, where I was showing you the zero product property in action. We have two things that are multiplying to 0. Of course, that means one of them, at least, would have to be 0, right? That only makes sense. We can only get 0 if we're multiplying something by 0. So what we're going to do is we're going to take this and say, okay, well, that means x times e to the x could possibly equal 0, or x squared minus 3 could possibly equal 0. And you get a lot of practice with this kind of thing when you're in Algebra 2, especially when you're in pre-calculus. But I just want to remind you that it's going to come up lots in calculus, especially in problems where you're expected to perform your work by hand, like on the AP exam. So if each of these things equals 0, what have we just done? No, of course not. If you notice, this is another case of the zero product property. So what this means is that either x equals 0, that's totally possible, we don't even have to do any work to solve that, or e to the x equals 0. And here's a very important feature about exponentials that you need to know, just to remind you. Any exponential expression is never equal to 0. E to the x will always be greater than 0. 3 to the x will always be greater than 0. Even 1 over 25 to the x will always be greater than 0. It will never equal 0. And that helps us because if we know that that's never going to equal 0, well, that just means that that portion is not 0. And if you remember, we looked at the property, it's just that one of them at least has to be 0. We don't need both of them to be equal to 0. Okay, so it's possible that your other factor does not equal 0. Let's look at this other case. We have x squared equals 3. Therefore, x equals plus or minus the square root of 3. And these are all of the values for x, which would cause the original expression to be 0. In other words, the solutions to the equation. That's how we would solve this equation. All right, great. Let's look at another example here. We make use of this all the time. When we're factoring, let's look at a very basic example of factoring. When we're factoring to solve a quadratic equation, or to solve any equation, we move everything to one side so that there's a 0. Why do we do that? We do that so that we can use the zero product property. This property does not work for other numbers. If I had something like x squared minus 7x equals 12, and then I factor the left side, I would not be able to use the property on this. I would not be able to say, oh, that means that x equals 12, or that means x minus 7 equals 12. No, that's not how that works. We can only be sure that a and b could equal 0 if our product is equal to 0. Because we can have lots of values. We can have 12 times 1. That'll give us 12. We can have 6 times 2. That'll give us 12. We can have 3 times 4. That'll give us 12. We could even have some non-integer numbers. We can have something like, 2.4 times 5, for example. So what are we going to do? Solve for when x satisfies all of these conditions? No, of course not. This would not be a good way to go about it because it's not equal to 0 at the end here. We would want to have this moved over, everything moved over to one side. And that's not actually the same equation because I put a positive 12 up there, so it's a slightly different equation. But my point here is that we can only exploit this property, we can only utilize this property, as the name suggests, when the product is 0. Now we know for sure that, okay, if these two objects, the x minus 4, whatever that number is, and the x minus 3, whatever that number is, the only way we can be sure that their product is 0 is if one of these two numbers is exactly 0. So then we can say, okay, x equals 4 would satisfy, and x equals 3 would satisfy. All right, so don't get lost in the sauce. Let's do a very, very involved example here. We're going to have, let's see, 4x cubed e to the 6x. Yeah, we're going there. Plus 12x squared e to the 6x. plus 12x e to the 6x is equal to negative 4 e to the 6x. So go ahead and try to work that out. Give yourself a moment. You can pause the video and give yourself as many moments as you need. Hopefully you don't take too many moments. And then when you're ready, you can unpause the video, come back and see how it's done here. Okay, there are a couple structures that I hid inside of this. Let's move everything over to one side. You know the drill. We cannot use the zero product property if there's not a zero on one side of the equation. So it's a great way to start. Let's add the 4e to the 6x. All right, looking better. If you notice, everything has a factor of 4 in it, and everything has a factor of e to the 6x in it. So there we go. And here we're left with x cubed because I took the 4 and I took the e6x, so I'm left with x cubed, plus 3x squared. Again, I took a 4 out of here, which means there's 3 left, and then I took e to the 6x away. Plus 3x, same logic with the 12, I took away a 4, and e to the 6x. And then if I took the 4 and e to the 6x, there's nothing left but a 1. So does this look familiar? This should look kind of familiar. It does not factor grouping, but it is the expansion of x plus 1 to the 3rd power. So now that I have factored this, I've condensed it into a factor, I can use the zero product property. I can say that either this thing here equals to 0, and really you don't need the 4, but you could include the 4. We say e to the 6x equals 0, or 4e to the 6x equals 0. Of course, we know that's not true. It's never true. Get used to seeing that, where e is a factor, and it's never equal to 0, so that kind of saves you some time there. And then we have the possibility that x plus 1 cubed is equal to 0, which of course would just mean that x plus 1 equals to 0. And our solution for that is x equals negative 1. That is the only solution to this equation. It's a good idea in general to check your solutions. Not just because sometimes there are extraneous solutions, but also because sometimes we make mistakes, make calculation errors. And if you try to plug this back into the original equation and it doesn't work, that tells you that you for sure made a calculation error somewhere. So let's just see how it works. I know it's a negative 1. It might not be pleasant to plug in. But let's see, we have 4 times negative 1 cubed e to the negative 6 plus 12 times negative 1 squared times e to the negative 6 plus 12 times just negative 1 e to the negative 6. And we can see on the original equation, I guess, we can see if that's equal to negative 4 e to the negative 6. So working out these exponents is not difficult since we're plugging in negative 1. Really easy. So this is just going to be negative 4 over e to the 6 plus 12 times positive 1. So plus 12 over e to the 6. And then here we have minus 12 over e to the 6. Of course, these cancel. And so, yes, this does satisfy the equation because negative 4 over e to the 6, that do be equal to negative 4 over e to the 6. Okay, so checking your answers is always a great idea. Plug it into the original equation and make sure that your solution is valid, making sure that it preserves the equality. Basically, it works on both sides. Okay, that's just a brief rundown on the zero product property. I know it may seem like a basic reminder, but really when you break some of this stuff down, especially when you get to pre-calculus and calculus, it's going to be better for you to visualize the simple concepts that lie behind all the distracting algebra, like exponentials and all this factoring. Those things need to be ingrained already. This is just a reminder about what we do when we're solving equations. Even if they look kind of nasty and ugly, we try to factor them, and then we can apply this nice zero product property. So I think that's enough blab out of me, and we'll catch you guys next time.